What's up, everyone? Welcome back. Patrick here. Moving on to another question, a word problem dealing with factoring. So we're told a shape has an area of this expression, 15x squared plus 19x minus 8. And we have to find a potential. There's two scenarios here. We have to find a length and a width if this shape is going to be a rectangle. Or part B, we have to find a base and a height if the shape's going to be a triangle. So part B is actually going to be a little bit more tricky than part A, but let's start off with part A. We've done questions like this before where we're given a rectangle and we're given an expression for the area, which in this case is that, and then we have to find an expression for the length and then the width. Now, the area of a rectangle, what's that equal to? Well, it's equal to just length times width. And so what we got to do is we got to take this expression, this 15x squared plus 19x minus 8, and we have to change it to be in this format where two things are multiplying by each other. So as you guessed it, we're going to factor. We're going to have two factors, and then those can be corresponding expressions for the length and then the width. So that's where the whole factoring comes in. So we're going to take that area expression and factor it. So first thing we check for, can we factor anything out? A greatest common factor? Notice in this case we can't, between the 15, the 19, and then the 8. So let's go straight into decomposition. C value is negative 8. Now the AC value would be negative 8 times 15, which would give us negative 120. So then we're finding two numbers that multiply to negative 120 and add up to 19. And what would those two numbers be? It would be negative 5 and positive 24. Negative 5 times 24 does give us negative 120, and then negative 5 plus 24 gives us 19. So then what we do, we decompose that B value into those two values that we found. And then we factor by grouping. So from these two, we could take out a 5x, and we'd be left with 3x minus 1. Then from these two, we could take out an 8. And again, we'd be left with 3x minus 1. Then we could take out a 3x minus 1. Right? These two brackets, they should always be the same. And we're left with a 5x plus 8. And so notice that we have our two brackets. So we got 3x minus 1 times 5x plus 8. And these are interchangeable. So you could have this be the length, this be the width. Or you can have this be the length, this be the width. I'll probably go with this one. This is a larger value, 5x plus 8. I guess it depends on what the x value is. But if the x value is positive, then this is going to be larger. So I'll make that the length. And then we'll have 3x minus 1 for the width. All right, so those are the expressions if it's a rectangle. So let me just write it over here. We'll have the length equaling 5x plus 8. We'll have the width equaling 3x minus 1. And again, both of those are interchangeable, but I'm going to keep it like that. So that's if it's a rectangle. So that's part A. Now, what about part B? Part B is a little bit different because what they're saying is we're finding the base and the height if this area here, it's the area of a triangle, if the shape that we're working with is a triangle. Now, if we have a triangle, just as a quick review, what's the area of that? Well, it's basically the base times the height divided by 2. So let's actually write that over here. We'll have area equals, let me first write it here, and then I'm going to write it in a certain format there. So we'll have base times height divided by 2. Another way to write this is if we take the 2 out, we could separate this denominator from these two expressions. It's like 1/2 times the base times the height, like that. Or if you want to put this in decimals, 0.5 base times height, right? All three of these expressions are the same. And I'm actually going to use this one over here. And what the challenge is going to be here is we need to take this expression, this area expression, and put it in this format. Now, because we're multiplying expressions over here, it makes sense that we're going to have to factor this, which we already did, right? So notice that we're multiplying expressions over here, but notice that this is not in that particular format. When we were dealing with a rectangle, it was nice because it was just length times width, right? But over here, when we're dealing with a triangle, we have this 0.5 in front. Notice we don't have a 0.5 in front here. And then we have the base times height. So the biggest challenge is taking this and somehow being able to put a 0.5 in front. So how can we do that? Well, what you can do is you can actually take one of these brackets and then just factor out a 0.5. So let's start off, let's do it with the 5x plus 8. You could do it with either of these because, again, these are interchangeable, but I'm going to start off with doing it with the 5x plus 8. So what would happen if we factor out a 0.5? What do we do when we factor? Let's say we got like a 3x minus 6. If we take out a 3, how we figure out what's left in the bracket is we divide all the expressions by what we took out. So we'd end up with an x minus 2. So same thing over here. If you're taking out a 0.5, don't get too nervous about the decimal over here. Same thing applies. You would just divide everything by what you're taking out. So 5 divided by 0.5 would give us 10. Then we still got this x here. Plus 8 divided by 0.5 would give us 16. Right? So if I take 0.5, if I distribute it in this bracket, we'd end up with 5x plus 8. So this bracket, 5x plus 8, is actually the same as these two brackets multiplied. So what we can do is take this 5x plus 8 here and rewrite it as this right there. So let me actually erase this. So we'll have 0.5, and then we'll have 10x plus 16, and then we still got that 3x minus 1 at the end. And now notice it's in that same format. This here is still this. If you took all of this and expanded it, you would still end up with that same area. But what we did was we just took those one of those factors, 5x plus 8, and we wrote it in a different format so we can match the format for the formula of the area of a triangle. And so from here we could tell, well, a potential is the base equaling 10x plus 16, and then the height equaling 3x minus 1. Right? So that's a potential answer. The reason why it says a potential here is because there's multiple answers. Like in part A, how we said it was interchangeable. Well, here we can actually interchange these two brackets. The 0.5 we can't really touch, but we can get different answers if we interchange these two brackets. So we let this be the base and the 10x plus 16 be the height. So that's another potential combination. But there's actually another combination that we could do, because instead of taking out the 0.5 from that 5x plus 8, we can also take out the 0.5 from that 3x minus 1. So another combination, so these are two combinations. Another combination is if instead we work with that 3x minus 1, if we take out a 0.5 from there, right, dividing both of these by 0.5 to see what's left in the bracket, we'd have 6x minus 2. So 3x minus 1 is the same as 0.5 times 6x minus 2, right? If we distribute that 0.5 in, we'd end up with that. And so what we could do is we could keep our other factor that we had, the 5x plus 8, And instead of factoring the 0.5 out of that, we factor it out of the 3x minus 1, so then 3x minus 1 changes to 6x. 6x minus 2, like that. Okay, and if you expand this, you'd still get that, right? So it's the same thing. So there's a couple of more possibilities with part B. So another possibility here is the base equaling 5x plus 8, and then the height equaling 6x minus 2, as you can see here. But we can also interchange both of these brackets. So we can also have interchange these two. We could also have the base equaling 6x minus 2, and then the height equaling 5x plus 8. Right? So 4 different combinations in part B. Okay, but the trickiest part is just recognizing that once you have those two factors you're multiplying, if you want to get in this format, we got to take out that 0.5 from one of the factors, and then we get in that format, and then it's easy to see what the base and height are.